graph the function by hand, not by plotting points, but by starting with the graph of one of the standard functions given in section 1.2 and then applying the appropriate transformations. So for here we have y, which is equal to the sine of x divided by 2. So we want to start out with the graph of y is equal to the sine of x. So starting with the graph of y is equal to sine of x, we're going to stretch horizontally by a factor of 2. So that means we need to multiply each x coordinate by a value of 2. So if we look at the points on our graph here, so right here, that's going to represent negative 2 pi and then 0. And then here, this is going to represent negative 3 pi over 2, 1. And then here, this represents negative pi and then 0. And then here, this is going to represent negative pi over 2 and then 1. And then we have our origin at 0, 0. Okay, so if we multiply each x coordinate by 2, then we get negative 4 pi, 0. We get negative 3 pi, and then 1. And then we get negative 2 pi, 0. And then we get negative pi, 1. And this becomes 0, 0. Okay, likewise, if we look at the positive versions, so if we take a look at here, this is now pi over 2, 1. And then we have pi 0. And then we have 3 pi over 2, 1. And then 2 pi 0. Okay, so again, we're multiplying each x value by 2. So we end up with pi and then 1. We get 2 pi and then 0. We get 3 pi and then 1. And then we get 4 pi and then 0. So now let's take a look at that graph. That graph states here that we have 2 pi and 0. So we can see that this is 2 pi and 0, and we know that we have 0, 0 here. And then this is negative 2 pi, 0 right here. And therefore we can see that it's stretched horizontally by a factor of 2.